Are categories from category theory design patterns? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So, I often hear people ask, these are object-oriented programmers. They're used to using design patterns, just for context. They're used to learning the visitor pattern, the singleton pattern, the factory pattern, and they ask online, what are the functional design patterns? And one common answer I see a lot is that categories, that is monads, monoids, functors, those are design patterns. That those are what functional programmers use when they're building their systems and their design patterns. And that's always struck me kind of the wrong way. It just doesn't feel right. And it's only been recently that I figured out why it doesn't seem right to me. When I look at the design patterns, what I see is code patterns that are not reusable in the language, right? So in Java, you can't write a visitor abstract class or a visitor interface and then just implement that, and now you have a visitor. It is a whole coding pattern that requires you, the programmer, to have a lot of discipline implementing that pattern. And so a lot of people would say that the design patterns are actually workarounds for limitations in the language. Okay. Now, when you say, well, functor is a functional design pattern, it doesn't carry that same connotation. You still, in Haskell, because the Haskellers are the ones who say that functor is the design pattern, right? Haskellers, static type people, they'll say, well, we have this thing called a functor type class, and we implement it, and then we have a type that is a functor. And it doesn't have that problem of it being a workaround for something that doesn't exist in the language. That's why, to me, it doesn't seem like that's a design pattern. And why is that important? That idea that it doesn't have, the language doesn't have the feature that allows for that design pattern to be easily expressed. Because I feel like what happens then is you don't have people looking for patterns that don't have features to support them. Okay, if I were going to use functors in Clojure or monads in Clojure, I would say that's a design pattern. Or I don't like the word design pattern, but I'm going to, work with the definitions and the terms that are out there. But if you have a functor or a monad in Clojure, because there isn't any support for that stuff in the language, in Haskell, you need the type system to basically make them work right. Because of that, I would say that they are a design pattern in Clojure. If you want to do a monad, it's a lot of discipline from the programmer. You have to learn how to do the pattern, and then you can code it up. And then someone else who looks at it, they have to learn this design pattern before they can understand it. Whereas in Haskell, it's written right there. This implements monad in this way. So there, you're done, right? It's not a thing that you have to learn separate as a pattern. So the problem is then the Haskellers, as an example, when they use when they use a design pattern, or when they use monads and call them a design pattern, they're missing other patterns. They're missing what their language doesn't support, but that they do all the time. And those are the things that actually need to get written down. Those are the tribal knowledge. Those are the things that a new programmer needs to be introduced to before they can understand what's happening. There's no syntax to look up. It's all discipline and patterns and just coding practices. And so if design patterns has any use at all, it's as that. It's as this thing that you can only recognize that it is part of the pattern because you understand the pattern. There's no piece of code that says this is the pattern and then it's checked by something. I mean, the same thing happens in Clojure with, say, lazy evaluation. Lazy evaluation, you could say it's a pattern. In some languages, they don't have lazy evaluation. But then in Clojure, we do for sequences. And so if I come to Clojure and I call lazy evaluation a design pattern for sequences, it's not true, like a lazy list. It's not a design pattern. It's just a fact of the language. But in another context, another language, you actually have to implement that. And it has a little bit of discipline, and how do you use it, and that kind of thing. So I think that at least in terms of Haskell, we shouldn't say that design pattern, that the monads and the monoids and the applicative functors, they should not be design patterns. Because then it loses the meaning, the important meaning, that this is something that you need to learn that's not part of the language. And that's what we need to be looking for to help people learn our language, to codify what we're doing. And that's why the Design Patterns book was popular, because people, they learned Java, they learned C++, they knew the language, but they're like, I need more. I need to figure out how to do more with this language. And the design patterns gave them recipes and things that they could follow and learn to make them better programmers, to give them the power that they needed in their language. And so that's what we need to look for in Clojure, in Haskell, in whatever language we're using. We need to be looking for those patterns that we use all the time that the language doesn't explicitly support. And so in Clojure, I look at stuff like using hash maps to represent entities. There's nothing in the language that says you should do that, but it's very common that we do that. And a beginner looks at it and is like, I don't know how to do this. And there's all these rules about it. Right? We're going to use keywords for all of the attribute names. Then the values are going to be whatever type is appropriate for that. Right? And then what if we need to give it kind of another bit of information about what kind of entity it is? Well, that's another pattern there. Okay, but you can also use hash maps as indices. It's an index where you get to look something up, but the keys and the values are all the same type. What's an example of an index? If I wanted to look up entities by key, I can make a hash map where the key is the key, the ID, sorry. Look them up by ID. The ID is the key, and the value is the value. Okay, so these are patterns that we use that the language doesn't have a name for. There's nothing in the language that says like entity, right, or index, but we do those all the time. So that's what we need to be looking for, and that's what I always look for, is what does the language not give us that people do all the time? All right, if you want to get in touch with me, I'm Eric Normand. On Twitter, I'm at Eric Normand, EricNormand. And you can also email me, eric@lispcast.com. This has been fun. See you later.